Hello everyone, this is Vignan, and today we're going to talk about Java 8 streams. So this is not a tutorial, this is just my views on Java streams and why I find it interesting. So people who are watching this video is for those who has some knowledge on Java 8 and they should also know a bit of streams. If you're looking for a tutorial video, I've posted some other videos. Please check that out. But this is just for the practical application of Java streams. Okay. So let's let's look at the functions. If you see, there are like one function. I mean, one method, a static method which I've written. It checks whether a number is prime or not. I mean, if you guys have done some lead code and all, you might be knowing how to find a number is a prime or not. Like if I pass 3, it's going to return 2. A prime number is a number, it only has two factors, 1 and itself. So my goal here is to print all the prime numbers in a given range using Java streams. So let's try to do that. I'm going to declare a stream, okay? I'm going to say, I'm going to declare a list var primes, and I'm going to say integer string dot range. You know that, right? Prime number is going to start from 0 to, so I mean, they're going to start from 2 to 100 something. I'm going to give the range, and I'm going to filter this, okay? So I'm going to take the number, okay? And what I'm going to do is, I'm going to check if the number is prime or not. So I'm going to pass into this thing. So this over here is going to go here and it's going to check whether it's prime or not, and all the numbers will be filtered. And then I'm gonna box it to list like this, box dot to list. Okay, and if I just like um, apply a for loop, and if I say prime, and if I try to print them, okay, oh, they're like prime, I'm sorry. Okay, let's see what it's gonna print. Okay, it did print all the prime numbers. If you see 2, 3, 5, 7, 11, 13, 17, and it did print until 100, like 97 is the closest number to 100. Okay, but let's do something interesting. Let's not use isPrime. Here's where I like streams. I'm gonna take another stream inside this. I'm gonna say inStream.range. Okay, see, I'm gonna represent this for loop. If you see, I'm this for loop is checking from 1 to the number, and if it finds any factor, it's incrementing it. So what I'm gonna do is I'm gonna write the same logic in one line. So what I'm gonna do is I'm gonna declare a range from 1 to the number itself. Okay, the number itself. Okay, I mean the number plus one, since I have to also consider the number, and I'm gonna filter it again. Okay, so what I'm gonna filter is I'm gonna take a like another denominator. Okay, okay, I'm gonna take something called y, and what I'm gonna do is I'm gonna modulus it with number and y, and if that equals to 0, all the range gonna be in the stream. And I'm going to check the count. This is a termination, so it's going to terminate the stream over here, and I'm going to check if the count is exactly 2. Okay, and if it's exactly 2, this range is going to contain them. And if I'm going to print the same thing, actually, if you see, it did print all the prime numbers. Okay, every prime number is pretty much there. So instead of literally declaring this method, I've used two streams, a stream and another stream inside the stream, and I've terminated it. And after getting the range, I've just boxed it to a list, and we have iterated everything. But you might ask me, what is the use? I'm doing the same thing anyhow with functional programming, but I could have declared a method like this. And why should I even use streams? Because I could have done the same thing without using streams. So let's try one thing. Instead of printing 100 primes, I mean the first 100 or 200 primes, I'll try to print 1000 primes, okay? First 1000 primes. So let's see what it's going to do. Okay, it has given the first 1000 prime numbers. Okay, that's good, not bad. Let's try to print the first 10,000 prime numbers. Okay, so let's try to print it. Oh, there's a bit of delay, but still 10,000 prime numbers have been print with Java streams. Okay, not bad. Now let's try to uh, get 1 lakh or 100K prime numbers. Okay, let's try to do that. Oh, that's what we are talking. See, that's what we are talking. It's delayed. It's delayed. It's delayed. But it's going to print it, but it's delayed. Let's see how long does it take. How long does it take? I'm going to count 14 seconds, 15 seconds. Oh my gosh, it's taking long. But it's going to print all the primes. Oh, okay. Within 22 seconds, it did print 1 lakh, I mean 100K prime numbers. So it has taken 22 seconds, okay, to print 100K prime numbers, okay, primes. But my question is, can we decrease this time from 22 seconds to something? That's where Java Streams is interesting. Yes, there is a way. If I say dot parallel, it's gonna decrease the time. And if I run this, it's gonna give me the same output, but a bit quick. See, it's 4 seconds, 5 seconds, 6 seconds. Oh, it has printed in 10 seconds. Oh, almost like 9 seconds. It has printed all starting from 2357 to 100K. I mean, almost the largest prime is like 9991. Oh my gosh, from 22 seconds to 9 sec is a huge upgrade. That is where we're talking. That is where the Java streams has a practical application. So this is what I wanted to share. So yes, you could have not used Java streams. You could have uh, manually declared a method to check the prime, and you could have iterated it. But when you have used Java streams, it did use your multi-threads, or cores. It did divide the process, and it did return you the result in the quickest time possible. So if you guys have done data structures and algorithms, there is this thing called time complexity. We call it O of n, O of log n, which is the smallest. But if you ask me, instead of O of n, this has been converted to this, and the time has been decreased by parallel processing. So that's the practical advantage of using Java streams. I hope you guys have understood. And if you like it, please share and subscribe and leave a like. Thank you.